Assalamualaikum and hello Dr. Fatima. I'm Nurul Aisha binti Muhammad Ansallah, metric number SM4695. So today I'm going to present about introduction. Clean water is the lifeline of campus life. Aligning with SDG 6 target at UMT, reliable access to water isn't just about sanitation, it's fundamental to student health focus and overall academic success. Next is about problem statement. However, a gap exists between students living in campus dorms and those renting off campus. Issues like yellowish flow, odors, and supply interruption raise a critical question. Is water equity being maintained for all students across Kuala Nerus? Now, I'm going to present about research question and objective. Our study aimed to bridge this gap. We are investigating how residential location affects supply stability, comparing satisfaction level regarding water taste and smell, and identifying the real-world impact of water quality on student well-being. So lastly, I'm going to present about hypothesis. For our data analysis, we formulated and tested 12 hypotheses using Microsoft Excel to ensure our results are statistically valid. Instead of looking at each question individually, we have categorized our methodology into four strategic areas. First, we analyzed the demographic and location patterns. We used the independent t-test to compare age different and chi-square test to determine if gender distribution varies by residence type. Second, we conducted a water satisfaction comparison. To measure the gap between on-campus and off-campus residents, we applied the Mann-Whitney youth test and one-way ANOVA. We also used the critical values test to see if satisfaction level change as students progress through their years of study. And third, we look at student behavior and correlations. We use Z-test for proportion to compare the water treatment habits and Spearman correlation to identify if the cost of water significantly impact of overall student satisfaction. Finally, we perform an impact of analysis by using the chi-square goodness of fit test. We were able to identify the most dominant impact of water quality on students' daily life and supply shortages.
For this study, a survey research design was to collect quantitative data from students at University Malaysia Terengganu. This approach is suitable because it allowed us to gather information efficiently from a large group of respondents over a specific time. The main purpose of this study was to measure student satisfaction with water supply and water quality. The study also compared the experience of students living on campus and those staying off campus. In addition, this research aimed to evaluate whether water service at UMT are aligned with SDG 6 with focus on access to clean and sustainable water sanitation. In terms of research instrument, a lot of methods we are used to reliable and comparison data collection. The main instrument was questionnaire, observation, document analysis, and pilot test. The questionnaire was divided into three sections. Section A focused on respondent demographic, and for Section B, we examine information satisfaction related to water supply, and Section C, we explore the impact of water use on student health and daily life. Response were measured using 5-point linkage, range from strongly disagree to strongly agree. For the research sample, total of 100 UMT students were randomly selected. The sample included students living both off and on campus. Data collection was carried out using an online questionnaire created through Google Form. The link was distributed through social media platform and UMT student group. This method made it easier to students to participate and allowed to research to manage responses efficiently. Regarding the study variable, the independent included factors related to water supply. The dependent variable focused on student satisfaction at the impact of water issue on their health and daily activities. Meanwhile, control variable include demographic factor. Overall, this method enabled systematic evaluations of student water satisfaction and water quality at UMT, while also support the assessment of sustainability goals related to clean water access.
Demographic profile of respondents. First, this session shows the demographic profile of the respondents. A total of 120 predicted in this survey. The demographic information includes age, gender, year of study, and resident type. This breakout information helps us understand who the respondents are before analyzing water quality satisfaction. Age of respondents. Based on the result, most respondents are between 21 and 23 years old, which represent 66% of the sample. It is followed by respondents at 18 to 20 at 28%. Only a small proportion of respondents are above 24 years old. Overall, the respondents are mainly young undergraduate students. Gender of respondents. In terms of genders, female respondents make up 73% of the sample, while male respondents account of 27%. This shows the survey is dominated by female students. For the year of study, most respondents are year 2 students, accounting for 62%. Year 1 students make up 29% of the respondents. Only a small number of students are from year 3 and year 4. This indicates that the sample mainly consists of students in the early stages of their study. Next, this slide shows the residence type of the respondents. 64% of the respondents live off campus, while 56% live on campus. This means that more respondents are living outside the campus area. In summary, the respondents are mostly female, aged 21 to 23, and year 2 students. More of them live off campus, which provides context for analyzing water quality satisfaction.
Hypothesis analysis 1. Exact test for two proportion. In this analysis, exact test for two proportion was conducted to compare drinking water treatment practice between on-campus and off-campus students. The null hypothesis states that there is no difference in the proportion of students who treat their drinking water between the two groups, while the alternative hypothesis suggests that it's a different exit. Based on the result, the p-value obtained is 0.0357, which is less than the significant level of 0.05. Therefore, the null hypothesis is rejected. In conclusion, there is a sufficient statistic evident to indicate a significant difference in drinking water treatment practice between on-campus and off-campus students.
For this study, I conducted an independent t-test to compare the ages of students living on campus and off campus. The aim was to determine whether there is a significant difference in their mean ages. The null hypothesis assumed that there is no difference. Meanwhile, the alternative suggested that the mean ages are not the same. After running the t-test on Excel, the results showed that on-campus students are generally younger compared to those that's living off-campus. Most importantly, the p-value obtained was approximately 1.07 times 10 to the power of -8, which is far below the standard significance level of 0.05. This extremely small p-value provides strong statistical evidence that the difference in mean age is not due to chance. Therefore, I rejected the null hypothesis and concluded that the mean age between on-campus and off-campus students differs significantly. Here, I conducted a one-way on about to test whether satisfaction levels differs across the different water sources. The null hypothesis assumed that there is no difference, while the alternative suggested that at least one group would show a variation. The test produced a p-value of 0.084, which is greater than the 0.05 significance level. Thus, we failed to reject the null hypothesis. This means the overall satisfaction levels are fairly consistent across the different sources, and any variations we see is likely due to random chance rather than a real difference between the groups.
Hypothesis analysis 2. Non-parametric test. For this analysis, a sign test was conducted to test whether the median time is 15 minutes. The p-value obtained is less than 0.001, which is below the significant levels of 0.05. Therefore, the null hypothesis is rejected. This result indicates that there is a strong statistical evidence showing that the actual median time is different from 15 minutes. For this analysis, we use the chi-square goodness of fit test to see whether all water treatment methods are used equally. Based on the result, the calculated chi-square value is 100.88, is much higher than the critical value 7.815. So, we reject the null hypothesis. This means the water treatment methods are not used evenly. Boiling is clearly the most commonly used method, while the other methods are used much less frequently. For this analysis, we use the chi-square test of independence to investigate whether the student years of study is related to their satisfaction level with water quality. Based on the result, the p-value is 0.53, which is greater than the significant level of 0.05. So, we failed to reject the null hypothesis. This means that there is no significant relationship between students' years of study and their satisfaction level regarding the water quality. In other words, students from a different year have a similar level of satisfaction.
For this analysis, I used the Brusque-Wallace test to examine whether satisfaction levels differ across the study years. The null hypothesis assumes that satisfaction is distributed equally across all years, while the alternate suggests that at least 1 year to be different. The test produced an H value of 2.35, which is lower than the chi-square critical value of 7.815. Since the result does not exceed the threshold and the p-value is well above 0.05, I failed to reject the null hypothesis. This means there is no statistically significant difference in satisfaction levels between study years. Overall, satisfaction is consistent regardless of the study year. For this test, I used the Mann-Whitney-U method to compare water satisfaction levels between on-campus and off-campus students. The null hypothesis assumes no difference in satisfaction. Meanwhile, the alternative suggests that residents affect satisfaction. The test produced a p-value of 0.206, which is greater than the significance level of 0.05, and thus I failed to reject the null hypothesis. This means that any differences in satisfaction between the two groups are not statistically significant. In short, satisfaction levels appear similar regardless of whether students live on or off campus.
Research reflection. Based on the finding of this study, several future scenarios may occur if water quality and sanitation issues are not properly addressed. Although no significant statistical difference were found, issues such as water, shelter, health impact, and daily inconvenience still affect student well-being. If these problems are underestimated, especially in off-campus areas, students may face higher costs and potential long-term health risks, leading to inequality between on-campus and off-campus students. However, proactive action by the university or government can improve water monitoring and management, ensuring a safer and more consistent water access in line with SDG 6. In terms of risk, relying on statistical results can be misleading. Similar satisfaction levels do not necessarily indicate equal system safety or reliability. This may result in poor planning and failure to identify vulnerable student groups. Therefore, applying the precautionary principle is important. Even without clear complaint, regular water quality testing and stronger monitoring system should be implemented to detect potential risks earlier. Overall, sustainable water management supported by collaboration and awareness program is essential to create a healthy, fair, and more sustainable learning environment for students.
This study assessed water quality satisfaction among UMT on-campus and off-campus students in relation to SDG 6. Students have adequate access to daily water, indicating a generally functional water supply system. There is no significant difference in overall water satisfaction by resident, age, or year of study. However, off-campus students are more likely to treat their drinking water, suggesting underlying concerns about water safety. Based on this study, I would like to give a few recommendations. First, UMT should continue regular inspections and maintenance of on-campus water systems to ensure consistent and safe water quality. Second, stronger coordination with Syarikat Air Terengganu 1 is recommended to improve water reliability in off-campus area around Kuala Nelus. Third, student awareness programs on drinking water safety and proposed treatment methods should be introduced. Lastly, future studies should include laboratory water quality testing, allowing for a more accurate assessment of actual water quality conditions. That's all for us. Thank you.